Okay, number 1. So we have this circle inside a square, and we have to find the fractional uncertainty in the area of the square over the fractional uncertainty in the area of the circle. Okay, so let's look at the fractional uncertainty in the area of the square. I think that's pretty easy. So this is D. This must be D as well. So if we're looking at areas here, the fractional uncertainty in the area of the square is just going to be 2 times delta D. Because D's are multiplied, D squared, that's going to give us 2 times delta D. The fractional uncertainty in the area of the circle is a little bit more difficult, I think. So we know that the area is equal to pi D squared all over 4. So if we take the differential of this, then we get dA all over the d here is equal to pi times 2 d all over 4. But for small errors, the d here is approximately equal to delta d. So this is going to be equal to 2 pi delta d all over 4. So the fractional uncertainty in the area of the square, that's 2 delta d. That's all over 2 pi delta d all over 4. So delta d's cancel, 2's cancel, the 4 goes up here, so it's going to equal to 4 over pi. So the answer is A, 4 over pi. Number 2, an object is launched upwards at an initial velocity plus u at an angle theta to the horizontal. Air resistance is negligible. At a later time, the object has a vertical displacement of 0. Very important detail here. A vertical displacement of 0. So what are the horizontal component of the velocity and the vertical component of the velocity at this later time? So the horizontal component of the velocity is pretty easy. Obviously it's going to be u cosine theta. But the vertical component is a bit more difficult. So it goes up with velocity plus u, therefore it must come down with velocity minus u. And the vertical displacement is 0, means it's gone all the way up and all the way down again. Therefore, the vertical component of velocity must be minus u sine theta. The answer is B. Okay, number 3. An object is released from rest down a frictionless ramp. The object then leaves the ramp and slides along a rough horizontal surface. The object stops in a distance s along the ramp. The coefficient of dynamic friction between the object and the rough horizontal surface is mu. What is the height of the ramp? Okay, so the change in potential energy is just going to be mgh, height of the ramp. And then once it reaches the bottom of the ramp, this energy must work against the frictional force. So we're going to get work done is force by distance. So the force is equal to mu times normal reaction times S. It's equal to mgh. This of course is mu times mg times S. It's equal to mgh. So lots of cancellation here. So h is equal to mu times S. Number 4, this one about the object of mass m falling through the air. Terminal speed is v for a short time. What's the work done on the air by the falling object during this time? So we know work done is equal to force by distance. So the force is just going to be mg. So velocity is equal to distance divided by time. So distance is going to be velocity times time. So the work done is equal to mg vt. So the answer is A, mg vt. Okay, number 5. An electric motor has an energy of 1.8 kilojoules transferred to it in half a minute. The efficiency of the motor is 40%. What's the useful power output of the motor? Okay, so the power then is just going to be the energy divided by the time. So the power is equal to 1.8 by 10 to the 3 divided by 30. That's equal to 60. But the efficiency of the motor is only 40%. So we're going to have to multiply that by 40% to get the useful power output. So it's going to be 60 by 0.4. It's going to be equal to 24. The answer is B. Number 6. Particle X has a small positive charge and is free to move. Y has a large positive charge and is fixed. X is initially moving towards Y. Y exerts an electric force F on X. Gravitational forces are negligible. The magnitude of the force exerted by X and Y is which option? Well, I think in this one we have to go for Newton's third law. For every action there's equal and opposite reaction. So I think this one is going to be C, equal to the magnitude of F. I'm not entirely sure about this, but I think it is C, equal to the magnitude of F. Okay, number 7. A ball moving horizontally strikes a vertical wall. The ball rebounds horizontally. The mass of the ball is m, and the change in magnitude of the momentum of the ball is delta p. So what's the magnitude of the impulse acting on the wall due to the ball? Well, we know by definition that impulse is equal to change in momentum. So the answer must be D, D delta p. 8. An assumption of the kinetic model of an ideal gas is that each particle is which? So you must know your assumptions here of the kinetic model. And if you do, the answer is B. Each gas particle collides elastically with the container walls. The answer is B. So we have two containers, X and Y, and they're filled with the same ideal gas, connected by a tube of negligible volume. The volume of X is twice the volume of Y. So X is held at a temperature 150 K and Y is held at a temperature 300 K. What's the mass of X? What's the mass of gas in X over the mass of gas in Y? So we know that PV is equal to nRT. So we can say maybe P1 V1 is equal to N1 T1. Put this over P2 V2 is equal to N2 R all over T2. So we know that the R's cancel immediately, and the two pressures are equal. So the volume of X is twice the volume of Y. So we can then say that 2 Vx is equal to Nx times Tx x, so that's going to be 150, it's already in Kelvin, all over Vx is equal to Ny, all over 300. So the Vx's cancel out, so this is going to be 150 over 300, of course, is half, so Nx all over Ny is equal to 4. The answer is 4. The number of moles here is equivalent to the mass, so we can use Nx over Ny. Number 10. Maybe this is one of the easier questions. So we know PV is equal to nRT. Therefore, nR all over V is equal to P all over T. So looking at the question now, we know P is equal to 100. Temperature is in degrees. We must change this into Kelvin, so it's going to 300. So the answer then is going to be a third. So it's going to be B, 0.33.